Hello reviewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about EV hot swapping batteries. So let's dive right into it. Now, what exactly is the problem with modern EV? Well, realistically speaking, unless you are used to hypercars, most modern EVs have the range and the power. Now that power part is also very important because think of it this way: let's say you are traveling in national highway and every Tom, Dick and Harry around you is driving at 120 kmph. You have to drive at that point. You cannot say, oh, I have an EV, it only goes to 80. That's not acceptable. So it was an issue in early EVs because the battery density was power density was not high enough, meaning it could not provide kilowatt, like oomph that you needed to, and range was also a very bad issue. But both of them, range and power, has been solved at this point in time. However, one thing that is literally the roadblock with everything else is charging time, meaning we are used to 15 minutes of refilling time. Now, irony is that we used to have basically electric power vehicles before petrol became a thing. So if that never happened, like, electric to petrol shift, we would be like, this is common, we do not care. But like now we are used to that 15-minute refilling time. And again, 15 minutes, that assumes your full tank is drained. But generally 15 minutes is what you expect when you are going to a petrol pump, unless it's super busy. But we are used to that point. It's like, 15 minutes, done, go home. Again, unless bus trucks, they do take longer. So why does any country want to invest in EV? Let's say India. What's in for the Indian government to invest in EV? Well, it does free us from import, meaning other country cannot control our fuel prices simply because it's like, conflict happen and they're like, we're gonna increase the price. It's like, we're like, what the hell did we do? It's like you had to fight with third person, had fight with fourth person, and I'm getting screwed because of it. Okay, that will no longer happen. Again, there are some price fluctuation even with import of lithium, but lithium is a mineral that will have much longer lifespan compared to petrol that you're gonna poof in few instance. So that is a very good thing for national stability, meaning the less imports you have, the more reliability you get. And on top of that, even if you are a country that makes its own oil, you still have to issue that you do not know how much oil do you have. Like, best estimates are just that, estimates. They are not like this is exactly we have. Again, many companies have invested in drilling oil wells and they're like, yeah, this does not have oil. It has happened more than enough time, and not to mention they do dry up. Again, how quickly, how often, that's a different thing, but it does happen. So it's one of those things that you want to be free from. It's like, I got this. You want something that you can say, I got this, not only for now, from 100 years from now. You want something that controls it. And on top of that, even if you have very doubtful view of, let's say, global warming, you have definite view of pollution. Nobody wants to be at the other end of a polluting car. That's a known thing. That's like, we got this, we understand that pollution not good, NOx emission not good, too much CO2, like around 13% is lethal. We know this for a fact. So we do not want something that whoosh whoosh, like producing GG amounts of pollution back of the cars. If that car becomes clean, it makes metropolitans far more livable. At this point in time, enough people are suffering because of poor air quality that people are taking serious notice. So it's desirable, but only one limiting factor that we have right now is charging time. And I'm not even talking about the cost, because again, levelized cost of ownership is more or less the same. So cost is not an issue, it's the charging goddamn time. So why don't we do hypercharging or booster charging, whatever have you, warp charging, this charging and all that? Well, you have to understand one context. Context is C rating, meaning 1 C simply means you are charging in 1 hour. Does not matter the capacity, meaning if it is a 18650, does not matter. If it's a giant car battery bank, it does not matter. 1 C ratings simply means 1 hour charging time. 2 C simply means 30-minute charging time. 3 C, which we want, is 15-minute charging time. Now, majority of lithium ion chemistry does not like it has a very small range of charging, which is much better than lithium ion basically lead acid charging, but we're supposed to be at 0.5 for maximum longevity, to like okay longevity kind of 1.5 C. And that's why all Android manufacturers are pushing like hypercharging that is going like 3C or almost 3C level. The reason for that is that it degrades lifespan so quickly that's like you're gonna have this phone, it's gonna be awesome, it's gonna have a huge cell, but here's the deal: if you overcharge it, you can easily get 3 years of usable life. But if you supercharge it every time, good luck getting 2+ years out of it, and then you have to replace it. So again, it's a very good, very clever planned obsolescence trick into it. Again, once in a while fast charging does not matter, but if it's much healthier for everybody involved to have like slow charging of like, let's say, 25-watt charging overnight. And yes, more than enough. Almost every BMS installed in every mobile phone has a way of cutting down the power when it's feeding to the battery. Do not worry about it's like, oh, if I left it, oh, it will overcharge. No, it's built properly, it's not gonna do that. Now, what if you really want that 3C charging or even faster than that? So basically, 5C would be classified as around 12 minutes, 10C is 6 minutes, 20C is 3 minutes, 30C is 2 minutes. So again, let's say you are talking about a bus, you want to charge that as quickly as possible. In those sort of scenario, there is only one chemistry that can absorb that kind of oomph, that is LTO cell. Now again, it is lithium and it can safely deliver, meaning you can buy LTO cells and even the manufacturer will say, we are rating the life cycles, lifespan, everything on 5C. 3C is like common for LTO cells. So you're like, why don't we use it everywhere? It's awesome. Well, it is awesome. LTO cells are awesome because they have very high temperature resistance, very long operating temperature, meaning from freezing cold to Indian deserts, is like, I got this, fam, don't worry about it. It's like, it's awesome. And you can even damage it, meaning drill through it and it will still survive. Not survive as in like it's healthy, it's like it will not catch on fire, it become a fireball. So it's kind of awesome, but it does have low capacity. Now think of it this way, range anxiety is like literally emotional thing, and we are anxiety about something that can go up to 300 kilometers without any issue, or almost 250 without even looking at it, and then we have range anxiety issues. Now what will happen if you have something like LTO cells? Everything is awesome, like even in crash it's awesome, charging time super awesome, longevity super awesome, but like, yeah, range is 150 kilometer. It's like people are like, no, I can't do that. So that's why we don't use LTO. However, in buses people do use that. Now like, why do we use it in bus? First, bus has a much more known travel, fixed travel kind of scenario, and not to mention bus has larger volume, meaning how many liters you can dedicate to battery is much higher, so they can do that. And that's how China achieved, like, 400 kilowatt charging. That's how they are achieving that, using LTO cells. And it does also have ludicrously long lifespan, meaning 15 years is acceptable, and people are achieving that kind of lifespan. Now there is another hidden cost to this, meaning let's say some engineer in the future figures out lithium ion capacity, meaning the kilowatt per liter, and adds the oomph of LTO cells. Everything awesome, every problem solved? Not really, because feeding that much power is expensive, meaning power is not just like electricity, take it and go. You also have to figure out delivery mechanism. For example, let's say you are talking about something, let's say Model 3 from Tesla, and it has like 100 kilowatt hour. Just go with that. It's a 100 kilowatt hour capacity, meaning 100 kilowatt for 1 hour. You have to give that load in order to charge that. Now you develop some awesome technology. Now you are charging it at 2C. Now here's the deal. The transformer that is providing the power to that charging station has to be around 200 kilowatt continuous rating. That's expensive. Now you made that go even higher up. Now it has to be around 400 kilowatt. You get that point? At that sort of power rating, company will simply not give you 200 volt line. They will be like, hey, I'm giving you 111 kV. Step it down to what you want. So that's another issue that you have to understand. Even if we can develop technology where you can charge, like, buses, like, done charging, you have to figure out how the heck you pump that much power into the system. The overall power consumption is not huge, but the amount of power like spike that you're putting, that is very stressful for the grid. I mean, like, that is so much that grid will literally sag. I mean, grid sagging simply means the RPM of the generators will start to slow down, especially if you have like hundreds of vehicles directly, like, 500 kilowatt charging, even for a battery that is like barely 30 or 50, simply because you want to achieve that 2-minute charging time. So that's another aspect of it. Power becomes expensive. And there is another issue, is like, basically, if once your power rating goes up beyond a certain point, every government will charge you much more for that, simply because it's much more expensive for them to deliver it. So it's not they are exploiting us, like, yeah, it's expensive for us to deliver you, so we have to subsidize the normal consumer with higher industrial prices. That's another issue we have to deal with. And let's talk about how the heck you're gonna pump that kind of power. You can't do that based on onboard chargers, simply because onboard charger with that kind of oomph will be too goddamn big, too big, heavy, and a dead weight most of the time. So that's why generally they have DC charging that is outside of the vehicle. Benefit: it can be big, it can be huge, it can be liquid cooled, and it could be parallelly stacked, meaning you go to any manufacturer, it's like, I want 400 volt DC. Expensive, but we can do this. You say 50 amps. Expensive, but we can manage it. You open their mouth and it's like, for car fast charging, it's like 400 amps. They're like, bro, chill. That's not happening. So what generally DC fast chargers do nowadays is basically they have multiple stacks. So each stack is only giving, like, let's say 20 amps, 30 amps, and that also has the safety advantage that if one stack fails, your whole DC charger does not go down. It's like, I got this. It's just charging speed will go down. So in those sort of scenario, it becomes ludicrously expensive, meaning 3-phase, even like, as high as like 10 amps per phase, or like 15 amps per phase, is not that expensive, because all it is electrical contactor with a basically low level microcontroller that talks. Is like, dude, only draw 10 amps or only draw 15 amps. That's it. It's super easy. But DC fast charging that can give you that, like, 3C charging for 100 kilowatt hour system, yeah, good luck. That will be idiotically expensive, even though the total energy consumption is more or less the same. That's why that's the hidden cost of doing hypercharging. And grid will feel it. Like, that's another aspect you have to understand. It's like, everybody started to do this sort of charging. It's like, grid had to be reinforced with, like, capacitor banks, so it can, like, I got this. So that's why we do not want to, even if we can achieve it, you do not want to do that. And not to mention, I'm not even talking about longevity. So what about swapping? Well, swapping is something that we are familiar with simply because it does work in small scale, meaning at the early developments of space shuttle and development of ISS, they wanted two people to go outside of space station and work, meaning have a drill, do things. And problem was they could not pull out a cord from the inside. So they had to develop nickel cadmium battery packs that was making power tools. And that became a whole industry on Earth. And then nickel cadmium was replaced with lithium ion. And right now you can just buy it. Like, it's a common thing. You don't think too much about it. You just buy into a system, meaning you can have like 18 volt from DeWalt, you can have 24 volts, 48 volts. You can just go buy, don't think about it. You use a power tool, it does have the oomph. Again, it can drill through things. Of course, it's high energy. It's a thing that we do. It's a common thing that we are familiar with. Same goes with camera. And these are the basically V-mount batteries that are generally used for cinema cameras. And it's a very old standard. So it's like, we got this. We sorted it out. Even with drones, because people figured out like connecting a plug, while it is awesome, it does work, it does have the consequence of adding the plug, adding if charger has to be outside. It's like, what's the point? Why not have two batteries, just the battery into the drone and charger charging another battery, so you can swap very easily. That does work. Like, that's how majority of the drone works. So it does make sense. However, there is a voltage limitation, meaning generally you're supposed to be below 50 volts, because the moment you start to cross around 50 volts, you are at a risk of crossing skin barrier, meaning electricity can go inside you, and it's not a very pleasant experience. Meaning that was another limitation factor of USB power delivery. When they wanted to like 200 watts of power, they can only increase the voltage to 48 volts. They could not go beyond that. The moment you go beyond that, it's very risky. Same goes for electric vehicles. The sub electrical system, meaning all the wiper motors and electric winch that drives your basically power windows, all of them are generally only targeted to 48 volts, simply because in a case of accident, you do not want 48 volts shorting to the chassis. If it does short, you're not going to be electrocuted. But if you have like, let's say 50 volts or God forbid 60 volts, yeah, good luck. 60 volt DC is very dangerous. Then you have to understand weight, voltage. Both have to be low enough, meaning voltage, let's say you get 48 volts, awesome. But here's the weight. How many people are strong enough where they can just like, pull 30 kilograms of weight, just like twink, twink, done. Very few people are that strong. And not to mention, even if you can do that one or twice, most of the time you will be so tired that, especially let's say you come out from office and it's like, it's not like morning jogging energy, GG amounts of energy. Most of the time you don't have that, and majority of the people don't have that kind of health built where they can like handle a 30 kilogram object. So it has to be light enough, it has to be low voltage enough for be safe. Now battery format is also another issue. Now every company, because of power tools is such a huge industry, every company has their own stuff. For example, DeWalt have their own standard which they built on different scales, meaning for light screwdrivers they will have low capacity system, for like big chunkers angle grinder they will have bigger capacity. Same goes for V-mount. Again, V-mount, because this is standard, it's already sorted and it's small enough that even a company like DJI flying system, they can manage it. They can concoct their own battery standards. So swapping is something that we know, and it does work, it does make our life easier. It's a known thing. So why don't we use it for EV? Well, reality is three things: size, weight, and voltage. All three goes YOLO in electric vehicles, specifically four-wheelers, meaning voltage crosses 200 volt line, average. Meaning there are some EVs that goes as high as ludicrous as like 400 volts or 500 volt DC. Now to give you a context of that, the only people who are qualified to deal with that is generally solar engineers. It is very dangerous because AC has this sine wave, meaning every time it is going to zero crossing, if you are getting electrocuted, you have the chance, that small window, that you can react to it and leave it go. But if you got zapped by a DC, there is no letting go. You're done. You left this mortal plane. You're gone. So that's why DC is very dangerous. It does not have that zero crossing, and that also has another side effect of arcing, meaning for some reason, let's say you started an arc with DC as low as like, let's say 70-80 volts. Once it started the arc will not self-extinguish, which will happen in AC, simply because when it goes to zero crossing, arc breaks, atmosphere stops it. But in DC, once arc is established, arc is like very low resistance, so it will continue working. So that's a very serious issue with solar industry. When they are daisy chaining very large amount of basically solar panels, the voltage can go ludicrously high. Some panels can go as high as like 1500 volt DC. That's dangerous. So you have to understand that voltage is not something to be trolling around. You cannot just like twing, twing. Yeah, you're gonna go up very quickly. Then we come to the weight aspect of it. Most people are not familiar with how heavy the EV batteries are, and I'm talking 100 kilo at very lightweight. That's barely like 100 kilometer range. When you're talking about like 300 or 400 kilometer range, you're talking about half a ton. Half a ton is not portable. That is not something that you can just like twink twink. Even winches will take very lot amount of time. Now this is a demonstration that was done by Tesla to show. It is in 2015 where they were swapping the battery. Now here's the deal, it can be done, all of these things can be done, but cost of doing it goes so high that people like, it's pointless. That's the reality of it. It's like, can it be done? Absolutely. I'm like, we do deal with higher voltage than this. We do deal with things heavier than this. We do know how to make a battery into a structural element. And that was another aspect that people realized over time, is that because battery is such big, such heavy, such a low center of gravity, it makes sense to make it as integrated to chassis as possible, simply because integrating it has the benefit that in case of crash, it acts as a good structure rather than a hardened, like, some engineers have to do that, like, okay, how the battery is going to react in a crash. No, it's like battery is the backbone. Battery is going to take the majority of the oomph. So that makes it much lighter and safer car. Now, if you have to make it swappable, you have to create what we call battery well, basically where battery goes in. And that also compromises your structural integrity. Now, you can reinforce it, but that adds what we call double walling, meaning you have an internal wall of the chassis, basically cell, and the cavity cell also is there. All of that makes it very inefficient. How do you extend the range of an EV? You make it lighter. How do you not make it lighter? By making it double walled. That's why everybody gave up on this. Like, more than enough company tried this EV battery replacement, but reality of all these three things combined, meaning the size, the weight, the voltage, translated to, can it be done? Yes, physics is not stopping. Engineering, yeah, we do have technology that can do this. That's how we manufacture cars in the factory line. But if you are like, wait a minute, that makes it expensive, duh. That's why even when E1 was being developed early on, they wanted to have that, like, battery swapping system, because they knew flat out E1s are like so pushing to the maximum, batteries will not last throughout the race. So generally they change cars in the mid of the race. And they wanted to have that battery swapping system. Every testing they did is like, dude, it reduces the capacity too much, simply because you have to have a structure that can handle a swappable structure. That made the well to be very expensive, very basically inefficient. Basically, reality was it was just cheaper to just have two cars. So that's why when you're talking about E1, they have battery car swapping rather than battery swapping. It just does not make sense. And not to mention, this can crash. It has to design in such a way that it will crash, it should survive. And battery was becoming a burden for the chassis. Chassis has to like, okay, driver, I'm gonna manage the G-shock on you. Battery, I'm gonna manage G-shock on you also. Now it's like, battery is like, I got this, fam. I got this. I'm gonna act as a mass shield to you. So that's why the reality is like, as early as 2015, Tesla did that and they abandoned it. And that's the reality of it. Every car company tries to do this and they're like, yeah, no, because that hydraulic ramp that can like, lift around a half ton, not expensive, but it's also not cheap. It's not something that you're gonna have like twink, plug, done, go home, sweet dreams. It's not that. That's the reality of it. So what we can expect in the future? Well, reality is people have to change their behavior. We are used to that petrol pump mindset. That's not necessary anymore, simply because if you take car, unless you're talking about commercial vehicle that is used 24/7, most of the time, most cars are static. It's just, that's the reality of the car most of the time. Even if you just put a normal inertial sensor in your car and just record how many times it actually physically moves, most of the time it's not. Now, what we have to do is basically slow charge it during that time, meaning it's healthier option, not only for the cells also, but also for electrical grid. Your grid is not going to be like, oh, somebody's putting 500 kilowatts on a battery that's barely 50 kilowatts. You don't have to worry about that. You're like, dude, relax. 1C charging, super easy. Quarter C charging, that's hyper easy. That's like the grid will not even notice that somebody started to charge their car. It's like, I got this. You want that. It's healthier for the grid and also for the cells that are inside your vehicle. And that's why even some companies like Tesla, they're like, if you supercharge too much, it's like, dude, we're not going to let you fast charge it fast as possible, simply because it will degrade your cell life. So that's why we have to change our mindset. We do not have to think it like petrol pump. I go to petrol pump to refill. We have to like, my garage is the petrol pump and I refill overnight. And again, you do want fast charging, but again, fast charging has to be sparingly used, meaning if you're traveling for long distance, then it makes sense. Once in a while, fast charging could even improve the health of the cell, because it does help with dendrite decomposition. Like, people have different white papers that I read on this. Is like, sometimes, once in a while, fast charging does help, but not every time. So, and again, three-phase AC 10 amp charging on each three-phase can charge electric car very comfortably in around 2 to 3 hours, very comfortably. How long do you park your car for? The answer would be more than 3 hours. How long do you sleep for? More than 3 hours. So you can easily, comfortably charge that. Now, what about two-wheelers? Now, two-wheeler battery swapping has been successfully done in Taiwan with this company. And the biggest complaint people have is like, the battery is heavy. That's why I specified, like, most people are not healthy enough where you can just like, and even they realized they wanted to use a bigger pack. They like did the public experience, and most people like, yeah, I'm not lifting it. One or two time it's gonna give you back ache. So they half the battery. Again, it is a bit inefficient if the battery was directly integrated into the scooty itself, but this was a good compromise. It does work, it does have range, and because they have so many swapping stations, even range limited as this, like around 60 to 80 kmph, kilometer range, they're happy with it. It's like, even if it's about to run out, I'm just gonna swap it. And most people in Taiwan, basically, where this is so successful, it's 1 minute away from a battery swapping station. That's how successful this is. But consequence, they did have to spend around 200 million or even more to make the battery swapping stations. And it does make their scooty almost theft proof, because even if somebody steals it, they can't use it. So there is no resale value for it. Yes, a person can steal it, but like they can't resell it. So first few generations, first time they were stealing, and because they failed to sell it, the theft of this system started to go down. So that is what we have to understand in the future. It's like we have to change our mindset. It's like if a car is in parking, even in office building, let's slowly charge it up. Slowly, 3-phase, even 2 amps slow charge. Whereas like, I got this, relax, take it easy, no problem, just refill up. Like as long as it refills faster than the battery discharges, is more than good enough. If you are charging like, let's say 10 kilometer per hour, that's very slow, but still would be good enough. And again, overnight charging, you can easily do 20 or 30 kilometer per hour charging. That's more than good enough. So this is what we have to understand. We have to change the mindset of like, DC fast charging, hyper charging, booster charging. No, it's like, again, those things are good tools and really important, especially for some scenarios. Majority of the time they are not. They are harmful for not only the electrical grid, they are also harmful for your vehicle battery life. So we have to let that go. Swapping battery only can be done on two-wheeler vehicles, two-wheeler systems. So this was my presentation on battery swapping and EVs. Hopefully you have liked this, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.